Let's look at a second part of this modeling tools with ODEs. I'm going to consider a potential V of x as before for Newtonian dynamics. But now the particle is not going to be given by its position and velocity. We are only consider that the particle is described by its position. And we write the dynamics of this from here. These are gradient flow dynamics because the evolution of x is simply given by the gradient of a potential. Now, what is happening here? The dynamics of x are going to be such that over time it goes in the direction of maximum descent of v, or the direction that minimizes v the most. And you can see this because the gradient at some point always gives you the direction of maximum increase. So minus the gradient gives you the direction of maximum decrease. And one way of checking this is to compute the derivative in time of this potential V, how it evolves over the dynamics. See, if I differentiate that just by chain rule, first I need to differentiate V applied to this point, and then differentiate x of t dt. And then this, because I know what it is, it simply gives me this relation here, which is always negative. This means that as long as the gradient of V is not zero, so as long as I don't reach a critical point of V, the potential is going to be decreasing over the dynamics. And actually from dynamical system, we will say that V is a strict Lyapunov function. In particular, if V has a unique minimizer, then you know that in the long-term dynamics, X is going to converge to that minimizer. For example, again in the case where we have a potential of the form x squared, so we have something like this, and now say we start again with our particle at this point here. Now we cannot talk about velocities because there is no velocity here. The ball in this case is going to evolve so that it minimizes the potential V, so it will go down, 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 and when it reaches this point, so the minimum of the potential, it's going to stay there. Okay? If you have more than one minimizer, then it's going to reach the closest minimizer and stay there.